Next is power. Power is defined as the time rate at which the work is done or energy is transferred. We can define the average power of a force as the work done by time taken. It is P average equal to W by T. And if time taken is very small, that is infinitesimal zero, then in that case, this power will be called instantaneous power, and that will be equal to elementary work done divided by the elementary time taken. And because we know that work is equal to force dot displacement, so we can write it is differential of F dot S. And in this case, if we consider that this F, that is the force, is constant, in that case we can take this force out of the differential, so we can write it is F dot ds by dt. And this ds by dt is the velocity, so we can write it is F dot v. So instantaneous power is equal to F dot v when the force is constant. The power is a scalar quantity. That means it has only magnitude, no direction. Its unit is watt, and 1 watt is equal to 1 joule per second, and it can also be written as 1 Newton meter per second. Further, it can be written as kilogram meter square per second cube. Its dimensional formula will be ml2t minus 3. Other units of the power are 1 horsepower, that is equal to 746 watt. 1 kilowatt is equal to 10 raised to the power 3 watt. One of the important unit which is commonly used is kilowatt hour. This kilowatt hour is the unit of energy, not of the power. We can write 1 kilowatt hour, which is the unit of energy, is equal to 1 kilowatt into 1 hour. That means a source of power 1 kilowatt, if we use for 1 hour, then that gives the energy, and this energy will be equal to 10 power 3 watt into 3600 second, or we can write it is equal to 3.6 into 10 raised to the power 6 joule. Let's take some examples. First question is, a body is moved along a straight line by a machine delivering constant power. The distance moved by the body in time t is proportional to. Options are t raised to the power 1 by 2, t raised to the power 3 by 4, t raised to the power 3 by 2, or t square. In the question, we will use the instantaneous power P is equal to dw by dt. And because power is given constant, so we can write it as dw equal to P into dt. Integrating, we will have integral of dw from w equal to 0 to w with time integrating with limit 0 to t. So on integrating, we will have w with limits 0 to w equal to p, and integral of dt is t with limit 0 to t. So this will give w equal to p into t. From work energy theorem, we know that this work will be equal to change in kinetic energy. Therefore, pt will be equal to half mv square if velocity is v after time t minus initially body is at rest, so kinetic energy will be 0. Therefore, pt will be equal to half mv square, or we can write v square is equal to 2 pt by m. This will give velocity v is equal to root 2 pt by m. We want distance moved by the body in time t. Therefore, this velocity can be written in terms of displacement, that is rate of change of displacement is velocity, so it will be equal to root 2 pt by m. Now to find the x, we rearrange dx equal to root 2 pt by m into dt, and integrating, we will have dx equal to integral of root 2 pt by m dt, and limits are for x from 0 to x, and for time it is 0 to t. So on left hand side we will have x with limits 0 to x, and it is equal to, here root 2p by m is constant, so it is taken out of the integral, and remaining is integral of 0 to t and root t dt. This will equal to x equal to root 2p by m into integral of t is root t is t raised to power 3 by 2 by 3 by 2 and limits are t equal to 0 to t. So we will have x equal to root 2p by m into 2 by 3 into t raised to power 3 by 2. So displacement, and in one dimension we can say it is distance, is proportional to t raised to power 3 by 2. Hence option C is the correct option. Second question is, if force F equal to 60I plus 15J minus 3K Newton and velocity V equal to 2I minus 4J plus 5K meter per second, then instantaneous power is. So power will be dot product of force and velocity. Force is given 60I plus 15J minus 3K dot, and velocity is 2I minus 4J plus 5K. On taking the dot product, we will get 9 terms, in which 3 terms contains I dot I, which will be equal to J dot J, and that will be equal to K dot K, and it is equal to 1 because angle between these vectors I and I is 0 degree. Similarly, J and J is 0 degree and K is 0 degree. While other 6 products will be 0, this is I dot J equal to J dot K equal to K dot I, and then J dot I equal to K dot J equal to I dot K, and all these 6 terms will be 0. So we have to take the dot product, that will be equal to the product of the I dot I, then J dot J, and then K dot K. So we will get 60 into 2 plus 15 into minus 4 plus minus 3 into 5. This will be equal to 120, then minus 60 minus 15, it is equal to 120 minus 75, and it will be equal to 45 watt. Hence option B is the correct option. Third question is, a particle of mass m is driven by a machine that delivers a constant power k watt. If the particle starts from the rest, the force on the particle at time t is. Because we know that force is the rate of work done, this is P equal to dW by dt. So this can be written as dW is equal to P into dt. It is given that power is constant, which is equal to k watt. So we can write it as dW equal to k into dt. On integrating, we will have integral dW from 0 to W. It will be equal to integral k into dt from 0 to t, and because k is constant, so it can be taken out of the integral and remaining is 0 to t dt. This will equal to integral of dw is w from 0 to w, that will be equal to k into integral of dt is t, and limits are 0 to t. On substituting the limit, first upper limit then lower limit, we will have w equal to k into t. As from work energy theorem, we know that work done will be equal to change in kinetic energy. This implies that kT will be equal to the final kinetic energy is half mv square at time t when velocity becomes v, and initially velocity is 0, so kinetic energy is 0. Therefore, we can write that kT is equal to half mv square, or v square is equal to 2 kt by m. This implies that velocity is square root of 2 kt by m. As we have to find the force on the particle at time t, so we have to find the acceleration. For acceleration, we again differentiate this velocity. Therefore, differentiating velocity with respect to time, we will have dv by dt, that will be acceleration, and it will be equal to differential of square root of 2 kt by m. Here, root 2k by m is constant, so we have to differentiate root t. Differential of root t will be 1 by 2 into t raised to power minus 1 by 2, because this is the differential of t raised to the power 1 by 2, so it will be equal to the power then t and then 1 by 2 minus 1, so it will be equal to 1 by 2 t raised to power minus 1 by 2 or 1 by 2 root t. So we can write it is square root of k by 2m. This root 2 get cancelled by 2 and t. So acceleration is root k by 2m into t. Therefore, force will be equal to mass into acceleration. It will be equal to mass into root k by 2mt. So we can write that force is equal to square root of k into 2t and then m. So it will be equal to square root of km by 2 into t raised to power minus 1 by 2. Hence option C is the correct option.